Welcome to the Software Lifecycle Stories podcast. We bring you stories of what worked and sometimes what did not in the course of discovering, designing, developing, delivering, and using software based solutions. As shared by practitioners who went through these situations. Dorai Thodla, known as Dorai to most, has been in the IT industry pretty much even before it became an industry that we know it as today. Combining his vast experience and his keen interest in spotting micro problems to solve, he has been a serial entrepreneur and a mentor for many students, as well as aspiring and successful entrepreneurs. He likes to call himself a technopreneur, working with product companies and startups. Join me in this conversation with Dorai. Hi, Dorai. Thanks for being a guest on this podcast. We've known each other for a long time, but for the benefit of our audience, I thought it is best if you can quickly introduce yourself.
Okay, I think it's pretty simple. Hi, everyone. I'm Dorai Thodla, but everybody calls me Dorai. I'm basically a technology entrepreneur. Been doing it since end of 1980. I started my first company at the time. I did 2 in India and 2 in the US. The fourth company, which started as iMorph and now it is Technology Strategies, is a small company that builds products. All my companies have been essentially either consulting companies in the software technology space or product companies. And they, of course, are inseparable in some sense. When you start building products, you also need to provide consulting. And then when you start doing consulting work, people ask you to come and build some products for them. And so we've been doing that. So that's about most of what I can talk about. Currently, I'm engaged in a couple of things. Since I have, the product company is like just a couple of us, I always wanted to keep them small. I also spend a lot of time running innovation programs in a couple of colleges where we take ideas from students and encourage them to build something that they can showcase and help them contain the scope and actually build a product. And so some of them are hardware products and electronics products, and some of them are software. The other thing I do is because I've gone through different styles of companies, I try to help startups, especially in the early stage where they have an idea and they want to validate the idea and they want to build a prototype and get some feedback. And so I act as a mentor through several organizations, including Chennai and NASCOM and various startup groups in India. And finally, I like to build communities. And so we develop small developer communities. And one of the latest ones I'm involved in is something called Build to Learn. I noticed that lots of students learn a lot of things in colleges, but they never actually build anything. So we meet once or twice a month, spend 4 hours. People come there with no knowledge of what to do, and we attach them to somebody who's interested in building something, and they slowly start learning by actually doing things. And that we have done, I think, more than a dozen. I think the last count is about 14 or 15 sessions of this, and it's very beneficial to the first timers. And it's also very beneficial to a lot of people who want to mentor students. So it's a great community. It goes between 20 people to 80 people depending on the time, and that's pretty excited about taking that and spreading it around. Other than this, I just track technology. That's my passion, and that's what I do most of my spare time.
Wow, that's a lot. I have, in fact, a few questions that I'll come to later, including how do you find time to do all this? But you always say that you are a micro product innovator. So what is a micro product?
So actually, it's a very loose definition. I don't think there is an industry term called micro product, but there is this notion in the software industry or in the startup ecosystem that you need to build big things to be successful. And to be very frank, you can build very small things and still be reasonably successful. Of course, your definition of success may vary from mine. My inspiration comes from a company it's called Norton Computing. and Peter Norton and 5 others. And at the time, I knew them kind of reasonably well. There were 6 people and generating $17 million in revenue. And there no marketing, no sales, nothing. And each one of the members generated, couple of $1 million. They wrote books, but they built amazing products like everybody may know about Norton antivirus, but before that they built the first disk defragmenter. And think about the technology that needs to go into building something like that. And a whole bunch of Norton utilities are very famous. So they built these little products, and they wrote about them. And sometimes it is books, sometimes it's articles. And it's a small group doing very high quality work. And I think there is a chance for lots and lots of companies to participate in this style of product economy. And so the best way to express that in a single term is microproducts. Is that microproducts is anything that a person can build in 3 months' time, or 1 or 2 people can build in 3 months' time, launch it, get people to use it, and even pay for it. And when you do that, and if the product is really good, lots of people will use it, in which case the direction of the product will be completely controlled by users. And that is what we really want. The product is not very good, you fail really fast because you're not spent more than 3 to 6 person months. And so I think it's a great way to enter the product ecosystem. And then microproduct is a starting point. If you want to take one product and become a really big company, nothing stops you from doing that. But if you want to produce a series of products, and this is ideal for solopreneurs. Solopreneurs are, single person entrepreneurs who are highly productive and really like doing fun stuff and creating things of value.
Yeah, wonderful. In fact, nowadays, people do talk about being a startup is very fashionable, and also all this lean startup, fail early, fail fast, and all that. I think all that you've been through. But then, how do you identify a problem to solve?
Okay, so my experience has been since 82 till now, right? So I'll go back to lots of stories in the initial stages because, that I think probably will give you a lot more relevance. We started before internet even started. Even PCs were not there that much when we started. So in 83, sometime in 83, 84, I was consulting for a company that was selling computers, and they wanted a tool to, run benchmarks, because at that time in India, every company would run a COBOL benchmark before they bought a computer, because they're actually buying 86 computers, but almost treated them like mainframes. So what we would do is the company that wants to benchmark would give them a COBOL program at the time, and they had to run it on 3 of their competitors or 4 of their competitors, and they had to run it on their own, and then show them some compile times and run times, and show that they're one of the top performers, if not the top, maybe in the top 2 or something like that. And then they would negotiate the price. And one of these companies I was consulting for came to me and said, Dorai, this is we're spending a lot of time and we're not able to get that many COBOL programmers. And sometimes it becomes, really, the differences are very small between these compilers. What can we do? And, that was, I think, one of the early product ideas. And I said, hey, why don't we write a simple converter that takes program in one format and converts it to program in other formats, and which was a very simple text-based, replacement. Just the syntax was slightly different in minor differences, because COBOL is a fairly standard language. And when I was looking at it, and I said, hey, why can't we write this in COBOL itself? And I think that was one of the first products. And I didn't know whether you can turn it into a product, but they were using it, and they saved lots of time, lots of money, because instead of people sitting there compiling, doing testing and all that sort of stuff, and they're able to use it. And then we improved it over a period of time, a couple of iterations. And so this is actually a problem and a solution turned into a product that can be distributed to anybody to use it. And, they could do this kind of thing. And that's when I started getting some ideas and saying, hey, maybe there are these little products that you can do, and you can help out people. The other one, which I think I'm pretty proud of and keep talking about it in every forum I can get, there was this company that had a COBOL compiler that was very slow, and they were losing a lot of benchmarks. But other than the COBOL compiler, almost everything else on that machine was really fabulous. Good product, very solid and based on technology from US. So I took a look at it and they said, hey, can you make the compiler faster? And I said, oh, I'm not a compiler guy. How can I make it faster? And then there are a couple of other constraints. We had no sources of the code, and open source was not very popular at that time. Or if it was popular, we didn't know about it in India. So we thought through the problem, found a couple of reasons why the compiler was slow, and then went and built some technology that made it run like 10 times faster. The compiler was the trick was very simple, and compiler was used to write a lot of files while it was doing the compilation because it had memory constraints. And all we did was we created a memory disk that the compiler thought it was writing to disk, and it was actually writing into memory, so it became very fast. And at that time I didn't know that you could actually take products like this and sell them internationally. So we did it more like on request, but it was heavily used. And then the company got back into the business of competing on compilation speeds and things like that. Like you get the early validation. It's a very clear metric on whether it's useful or not. And it is a bounded problem, is that in the end, whether compiler ran faster or not, and you run it without this accelerator and with the accelerator, see the difference, and there's no ambiguity about its usefulness. Yeah, going back to your question, I think the only way you can get realistic product ideas is to soak in the problem space. You pick a problem space and you spend a lot of time, you look at things that are blocking people from moving forward, and out of that comes idea. And if you know technology enough, you can always find a technology solution to a product.
Yeah, that's actually very nice. So have there been instances when something that you developed and the actual use case was different, that it surprised you? Because I had heard, for instance, in a different industry, that a washing machine maker suddenly found that there were a lot of machines being sold in Punjab. And when they wanted to find out, they were actually using it to make lassi. So something like that, what was not originally intended, but then you found it kind of amusing or surprising.
Yeah, I think that tend to happen with certain products much more than other products. In this particular lassi case, I've heard the story also, and it's hilarious. But that was clever innovation by the users of the product. And they said, hey, we need to mix a large amount of liquids, and this is how we're going to do it. And they turned a washing machine into a mass milkshake kind of stuff, in which is lassi is basically yogurt and plus some fruit or something like that. But the more vertical the product is, the less chances of it being used in different contexts. But most of the products we build are horizontal products. Like, for example, there's a product that we've been shipping since 2002. It's called InfoMinder. It is born with a very simple idea, and I'll talk more about it later. But essentially, it tracks web pages and sends you alerts and notifications. And I built it because I was tracking about 300 pages on the web, and I said, hey, I can't go and spend a minute on each one of them every day. So I wrote this tracker. First, it was a Perl script written by one of my friends, and then later turned it into a full product. And then we gave it away to a bunch of people, and then saw people using it, and then turned it into a product. And you can't believe it if I tell you, but 16 years later, it's still being used. People are still paying for it, and we have zero marketing sales. And it's one of the few. It doesn't generate large amounts of money, but it generates a steady stream of revenue. That product surprised me because I built it to track bookmarks. When you bookmark large amount of pages and you want to see what changes, and then you can get alerts, and I look at the alerts every day, and that's what we built it for. But I found that once we gave it to people, it was used for a wide variety of applications, things that I never even thought about. One company was using it to track movement of senior professionals on websites by looking at the team, and then use it for recruiting purposes, like people who left, or people if there was a VP who left, they would track the VP down, vice president, and then try to find him another job or something like that. This was before the days of LinkedIn, right? Now I think it's much easier to go to LinkedIn and do some of these things. But the strangest case was I got a call from a guy, and this guy said, hey, I'm interested in using this product, but I want to know whether you can send me alerts like 3-4 times a day. And we had restricted to just sending alert once a day because we don't want to keep on going and looking at a website, and because we'll get blocked. And I said, yeah, but tell me why you want to do it. This guy is somewhere in the Bay Area. He's a guy who does roof inspections. In the US, like in many other places, if you want to sell your house, you need to get a roof inspection done, and you need to get a certificate. And there are certain people qualified to do that. And the way they get the business is they just go and see which houses are on sale and then do that. And this particular person had a competitor whose wife was going to the internet and looking at these MLS listings and what is called multiple listing service, where houses are listed, and sending him messages or call. He would call after he fixes inspects one roof. He'll call home, and his wife say, "Oh, why don't you go to this other place where they are wanted?" And so these guys used to do that. And the person who approached me obviously had nobody at home who can do it for him. And at that time, internet was not that easy, and smart mobile devices didn't even exist, kind of thing. And so he said, "Hey, can I use your product for just tracking this website where they list all the houses ready for inspection?" And it's a use that I think I would never have thought of when I started building the product. And this is not just one. There are like dozens of stories like this, and I was pleasantly surprised at how different a product can be used for.
Yeah, amazing. I think never underestimate the ingenuity of users, right?
Yeah, that's true.
Yeah. So actually, that brings me to another related point, which has been also one of my favorite things about how do you build, whether you call it the mistake proofing in the products. When you build something like this and you don't know the users, or users are either too experts or specialized, or anybody can use it, particularly for horizontal products. How do you make sure that whatever you build, the quality is good?
See, there has to be some minimum quality without which you can't put a product out to beta. And that comes out of experience. And, the first few products we built, we didn't have a unit testing framework or black box testing or something. And we'll just give it to a bunch of users and they'll find out. So the products that, the like Infominder that I'm talking about, essentially what we did was we give it to a bunch of users and we have a beta period. Look at what Google did with Gmail. They were in beta for a few years, right? You just keep giving it to people and then let them use it, and they will tell you, because you can actually go and thoroughly test it and then, take a long time to get into the market. But the biggest risk in a product is not the little bugs that are going to stop you from doing something. It is the basic usefulness of the product. And so there is this dilemma that most of the startups and product startups go through, is that, hey, even if I give it away free and even if it works perfectly, will anybody ever use it? And so the best way to find that out is to offer it to people. And the moment you start offering it to people, you hit a whole bunch of problems that have nothing to do with product. First of all, how does the world know that your product exists? Today you have things like Product Hunt and other similar sites, but your first problem is, hey, I have this great product. I think it's pretty cool because I've been using it for X number of time, and a few of my friends have been using it, and we all find it useful. But how do I convey this to the rest of the world? And I'm not a marketing person, right? So it used to be very difficult before. It used to be expensive, but once the internet came about, and it's become a little easier, but not a whole lot easier, because there are millions of these products around the world. How does somebody discover the product? So I think I'll fix that problem first, is that proving the usefulness of the product. And then if it is really useful, people will start telling you that, oh, there is this problem, and or how do I do this? And sometimes they may not even know that you have this functionality. They'll say, hey, can we do this with this product? And you tell them, oh, that's a feature. You just go there and click on these two menu items and go to the third page, and there is this little thing that you can do. So lots of times even the feature discovery is, because you don't necessarily write good documentation, not people ever read documentation. So that is one thing. Second thing is that there has to be a basic quality. That is, the product should not crash. The product should, when you put it out, should function as people expect. And that is a tall order because you don't know what people expect. So one of the reasons why a lot of people say that, hey, you build something to scratch your own itch, you fix that problem by using it, and you expect X out of this product, and you're going to find similar users. That is why you take care of. Sorry, that's how you basically take care of this mystery about, hey, is it useful? Is it usable? All those kinds of things. Because if you're constantly going to use it, in American terms, that it's called dog fooding your product. And it's easy when you build products that you can use. It's much more difficult if you're building a ERP system for a company, an enterprise, and you are not one of the users of that system. How do you know how people are going to use it and what are they doing currently? And so you have a different set of challenges. With microproducts, you don't have, right? You either build it because you needed it, or you know how to use it, and you can map yourself to the same problems that the users have, and that is the best way to go about it. Sometimes it may not be possible, in which case what you do is that's why you get a user group to test it. So one of the early identification things that you need to do is to find users who are typical users. So if your product has more than one type of users, find groups of users, but pick one major benefit this product provides to users, and then get the users to realize that benefit, and then help them realize that benefit, and see how difficult it is for them to realize it. And if it's very difficult, you already know there is something wrong with the product. Is that so I that is the approach I would take. When you say beta or alpha, previously, when we had no internet, none of these kinds of things were there. Even companies large companies like Microsoft would release several beta versions or alpha version. Then alpha version is just barely features. You should not, may have bugs, but no showstoppers. And then beta version is almost complete but not shippable yet, or you can't charge them for it, kind of stuff. And then, but today the problem is a lot less because of cloud and SaaS, software as a service. You can incrementally roll out features. You can start with the minimum core that is really useful, and then slowly start adding features. And then you can instrument it in such a way that there are techniques today where certain new features are available only to a certain class of users. Facebook does this all the time, and most of the cloud-based products do this all the time. And you'll suddenly see a feature in Twitter or Facebook that's available only to a small group of users, and so there is engineering solutions to this kind of problem.
Yeah, nice. So the related thing is, you also have been working a lot with students, you said.
Yeah.
Right. And related to that, when you mentioned this build to learn, right?
Yeah.
Which is also probably twisting the whole thing, which is against the normal thing, saying you go somewhere, you learn to build or you learn to do something.
Yeah.
And then you also, I know you talk about thinking about thinking, or learning to learn, those kinds of things. So when you kind of abstract or take some of these things to a higher level, how does that help you? Is this something that others can also use?
Yeah, I think it's like the learning to learn is meta learning, right? And thinking to think is meta thinking. So what happens is there is an actual problem. Students and computer science engineering student today learns about 3 to 4 programming languages. Especially if you're Nana University, everybody starts out with C. Then they learn C++, and then they learn one of the things like either Java or C# or any of these things. They're all fairly related languages, so it's incrementally they get to more complex kind of things. But if you look at the system has a lot of theory, and maybe like a couple of hours of practicals, maybe 2 practical sessions in a week, 2 hours. And they're given a list of problems and they're supposed to find the solutions. And students apply the same technique they apply to their theoretical study. They're saying, okay, I'll mug up all these 20 programs. And if anything comes, I'm just going to just, reproduce it. The funny thing is that that is encouraged. In fact, I've heard cases where the teachers will look at your program before you enter it into the computer. And then even if one variable has a different name, they will say, hey, no, you can't enter the program because it's wrong. Wow. They say, no, but this is like a different algorithm. And I have one really frustrated user. Now I think he used to work for Wikimedia Foundation. Now I think he works in Berkeley on Jupyter. He used to tell me that, hey, most of those programs are fairly dumb and I could actually reduce it to half their size and write it, but I was never allowed to input them because there is no way for the teacher to verify. And that's sad. And so what happens is about 70 to 80% of the students come out thinking that programming is another mugging job. And I say programming is very hard because I need to mug up 20 programs to get answers. And this is, I think, uniquely Indian in some sense. May not be true in some of the better institutions, but it's true in most of the institutions. So one thing that we noticed was that people were scared of doing their final year projects. So some of them used to just go buy it. Not all of them, but some of them. And I used to ask these guys, why do you buy it? Because they said, I don't know how to write this big program. And they give me some IEEE paper. I'm supposed to read it and then I'm produced its project. And I have no idea how to go from reading a vague spec to a concrete implementation that works. And I'm scared of failing in this test. And so it's a very legitimate reason. So we said, okay, let's start doing these simple sessions. Like we started these programming clubs. And the programming clubs is where everybody comes and nobody knows anything and everybody writes some programs and people help each other and then get it to work. You won't, I don't know whether you experienced this before, is that one of the biggest joys in creating something is to see it work first time. And then, hello world programs are easy to write now because in Python it's just one line. But even if you write a simple Fibonacci series or draw a small house using turtle graphics or any of those kinds of things, and the first time you see it working, you say, wow, that's pretty cool. All I did was type in some 5 to 10 lines of code, and then here it is producing a beautiful graphic. So first, you need to introduce them to the joy of programming, joy of creating things. It doesn't matter what they create. And then slowly increase the complexity of what they're building. And the way to increase complexity is show them how to reuse the stuff that they have already done. These are all good software principles anyway. So I introduce functions when I'm teaching programming in the second session itself. Because, say draw a square using a turtle graphics and then turn square into a function, then start reusing the square and then draw squares of different sizes, parameterize the length of the side and that kind of stuff. And so they start getting a complex thing. Oh, it's not that complex. Once I write something and I can package it in some certain way that I can reuse it, then I can use it as a building block for building something else. And that is not taught in classes. Right? Because they don't have that much of time, covering the syntax. When they say cover the syllabus, they have to cover the entire syntax of Java. You need to get them, work on 20 programs and that kind of stuff. So we started with that. And then we said, okay, this is fine. And then I noticed one problem. And I said, when I told somebody, hey, go build a simple program to, for a bookstore business. And then they said, what is bookstore business? And said, okay, imagine there is a list of books. Somebody comes and searches for a book and they should be able to find a book and find out which shelf it is on. That simple. And somebody enters all this information about book titles and authors and shelves where the books are there. That requires a basic, simple database design. One table, a simple ability to take this search and then apply it, generate like 3 different types of searches, one for author, one for book title, one for partial book title. You have to, when you start thinking about it and they start implementing it in small bits, then we realize that, oh, okay, then I need a user interface. How does the user enter the query? And I need another user interface for entering new books. Should I upload them using, a CSV file or an Excel file kind of thing? And so incrementally they start realizing the problems that they need to solve to implement such a simple application. And we realized that none of them knew that when you gave a problem at that level, which most of the industry people think, wow, that's a simple problem. Is that, search a list of items and show the results. And seems like a simple problem, but when you give that problem, students do not know how to take that problem and end up with this bunch of functions that actually perform. So notice that, hey, there is a gap here. And even though they are taught UML diagram, software engineering and all that sort of stuff, it's too abstract for them. So we want to make it concrete. And that is what these sessions are about. And this cannot be done in like half an hour's time or 15 hours, 45 minutes, which is with their class, or 2 hours, which is in a lab. We said, hey, come here, sit, and there will be somebody experienced who can help you if you want. But try it yourself and pick a problem, small problem to solve. No problem is small enough, but it should show something in the end. You should be able to demonstrate something in the end. So they learn a little bit about the user interface. They'll learn a little bit about the underlying database design. They know a little bit, in this case, if they're building a web application, the front end and the back end of the web, and what is a REST API. All these little things come, but if you take all these topics that they learn by doing and make a list and teach them in the class, they'll be bored out of their mind. Programming is like, cricket. You can read a lot about cricket, watch a lot of cricket matches, but unless you take a bat and get into the field, you won't know how to hit a ball, or unless you take a ball and throw it, you don't know how to actually bowl, right? And it's a practice-based discipline. And then theory is good, and knowing algorithms is great, but knowing how to use the algorithm and why to use them is equally important. And that's essentially what we are trying to do with Build to Learn.
Wow, wonderful. Yeah, that actually answers a question that I wanted to ask, but anyway, I will still go ahead. What qualities do you think students need? Everyone talks about this gap between academia and when they get into the industry or actually working. You touched upon a lot of things in terms of the curriculum or how some of these topics are treated. But as an individual, an aspiring student, first of all, goes through all this in academia, is prepared to, or rather he's prepped up to be an individual contributor, and then probably better than the others and so on. So from that to more of a team sport, even if it is just one more person that you're working with, what have you found, and what would be some tips that you would give them?
So I think individual contribution initially is good, because what happens is, otherwise, if you are not a very persevering person, that is, it's easy to turn around somebody and ask them a question. And normally it tends to be teachers, teaching assistants, or lab in charge, or whoever. And then initially you need to struggle a little bit. What I do when I teach is I tell them right up front that I'm terrible in typing. I'm going to make lots of mistakes when I'm typing code, and I always type code in front of them. I don't copy paste or anything like that. And then see the thinking process. As you're typing the code, you keep explaining, okay, this is what I'm thinking, and then I make a mistake. And then suddenly I look around and say, hey, there is a mistake. And even before I ask for help, 3 students will say, sir, you missed that semicolon there, or sir, you named this variable wrong here. They're watching, they're observing, and they're doing this kind of. Doug Engelbart had this, he's the person who invented the mouse and co-invented hypertext, and he did some amazing things in his life. And had the chance of meeting him and working with him for a couple of years, he had this term called something called QWAC, KWAC, and we used to joke about it. It's called Knowledge Workshop Architect. And essentially what he says is that you can learn more about an editor like Emacs or VI by watching somebody edit than a practitioner. So you need this, it's kind of apprentice style programming, right? Where you sit with somebody who's very good, and then they start doing it and said, how did you do that? How did you do that? And this is what I think part of pair programming success is, is that you need to be exposed to doing things that you've never done before, because you don't even know what to look for. So these Build to Learn sessions will make that happen. But going back to your question, I think there are several things, right? Give them really small problems, but don't wait till the final year when they have to do the project. So what we started doing was we started doing what are called mini projects in the third year. In this college, it's called KCG College of Technology. We started doing micro projects in the second year. Now, I think at the end of first year itself, we are going to ask them to start doing some things. So thanks to technology development, now I think there are these Lambda functions. The Lambda serverless computing, and all these things are becoming popular, right? What people can do is write really tiny functions, and then initially show them, just give them a spec on writing a ton of these functions. Then asking them to thread these functions together to build little nano products, or Udacity is a nano degree program, right? So it's like something like that. And then, build micro products out of it, and then take these micro products and give it to people to test it. So when you get to a level of complexity where a single person cannot understand the whole program, you have a small team working on it, and then you divide the work. And maybe somebody does the front end because they're very good in design. Somebody does the back end. The front end is all now JavaScript and React and Angular, Vue.js, and all those kinds of things. And the back end could be your favorite programming language. Used to be PHP before, Python now, Ruby, Java, of course, and any of those kinds of things. And then some database. Many of these good programming languages also have object to relational mapper kind of thing, but initially they have to directly write database statements themselves. And so this is and then rotate them, move the backend guy to the front end guy to the database, that kind of stuff, so that you can build a full stack programmer. But the interesting thing is not full stack. They need to understand from the time they type one character in the keyboard to the time they see one character back on their screen, what really goes on. What happens when you type this character? Who's handling this? Where is it going in? What is going over the internet? What is the server receiving? What happens on the server? What does the web server do? What does the application server or the application attached to the web server do? How does it access the database? How does it get information back? The entire round trip, they have to know that. Then once you start understanding this, and do it with the smallest, the simplest program possible. So we actually ask them to do a simple to-do list, the simplest possible ones: add an item, delete an item, change an item. To-do list consists of just one field and maybe a priority. And then we introduce add priority. Now you sort it by priority. Then add date, due date. Now you sort it by due date. So you can take the small thing, smallest possible thing, teach them how to do it, demystify the whole thing, show them what happens at each one of the stages, and that will give them a lot of confidence. See, out in every engineering institution I've seen, there are normally a few really big stars. There are very few, 3 to 5 people, sometimes maybe only one in each batch, but sometimes 3 to 5 people. And these are all the kind of people that Googles and the Facebooks and the LinkedIns of the world, Microsofts will hire. And how do they get to where they got? Because they were very interested in programming when they were in school, and they never lost that interest when they came to college. And they've been hacking and building things right from their first year. And I normally identify the first years who are enthusiastic about programming are the ones that I pick into all these programming clubs. And a few of them inspire a lot of others. In fact, some of the people that I work with, at least I can give you 2 or 3 cases where they not only learned a lot of things on their own, but they also taught a whole bunch of people, because they want company. Yeah, like this guy by name UV, I mentioned 2009 when I walked into KCG, and he was one of the programmers. And I know we used to chat about this, and he used to be frustrated. He used to bring home his friends and teach them JavaScript and wanted them to build something, and used to be frustrated when they didn't do it, kind of thing. And I have now an intern by name Ashish who does exactly the same thing. He's teaching. He was saying, I'll produce 4 people for you to take as interns, because they'll pass. I'll make them pass this, this tough test we normally give to interns, and without showing them what the problems are, and I'll bring their skills up to that level. So the good ones, once they get confident, have this urge to share that, and it happens a lot among students. They do combined studies, and they do. The good ones are really, really good. So if you can seed them, and then if you can make, and students can teach other students better than teachers can teach students, and not because teachers are not good. It's just that teachers are at a different level of understanding, whereas students know exactly what other students' problems are. And even the ones who have gone past all the initial stumbling blocks and have become experts, even they can relate to the problems of the students. And students are fairly frank about telling others, hey, எனக்கு புரியல, tell me what it is, and I don't understand this thing. And they're not shy to ask for help. So I think putting groups of students together, doing a lot of little projects. I would put a weekly hackathon, in place, 4 hours. Sit there and just build something. Don't worry about the output. Don't judge it. The fact that you can sit for 4 hours and code and test itself is a skill that you need to build.
Are there any plans to take this beyond? I'm assuming it is all running in Chennai now.
Yeah, right now we're running in Chennai. I've had some requests from Bangalore to do it. We tried a couple of variations. We just did our first hackathon. It's actually MLH. It's a GitHub-sponsored hackathon. I think happened in several hundred locations, and we did it in Chennai. There are variations of this that we are trying to do. So our theme is basically build to learn, learn to build, right? Then a couple of cheesy things like learn to learn and learn to earn and those kinds of things, right? You can play around with words, but essentially we want them to move from building to learn, and then learning how to build, and then how to take things that they build and then start getting these small projects and stuff like that. We're trying to figure out whether we can do it, scale it by using online, like coding competition style approach. We're looking at that because physically there are about 3-4 of us as volunteers, and I think the volunteer group is growing a little bit, but traveling, many of them are students and a couple of them are working, and traveling around and doing it is difficult. So we want to bootstrap it in a few places, but what we decided finally is to do themed versions of build to learn. So we'll do one build to learn session will be Android, and where they'll be initially taught how to build an Android application. Then everybody will pick one application to do, and then they'll build it over a period of time. And it's a very what is called not instructor driven, but very lead driven approach, where a project lead or a team lead or a tech lead will guide them, guide 3-4 teams kind of stuff. And once we work out the mechanics and then we are happy with how we are doing it, then we try to set up a Slack group to see whether we can get it done online, but somehow it doesn't seem to work very well. So we need to crack that part. And so we are introducing them more and more to online competition. So we're going to go from offline competitions to online competitions. This year, 2019, that's every month we'll do one mini hackathon, and we'll probably do it in a couple of colleges, but we'll also do it independent of all colleges, so that anybody from any college can come and join this kind of thing. And the mentors are all people who are working, because a lot of startups looking for interns, and the biggest problem is they can't find an intern where they can point them to something and they go and build it, right? They need to guide them and spend a lot of time with them. So they would like some higher maturity level of interns, but if they know that they built like 3-4 little tiny products, and even if 70% of the code is copied from some GitHub repo or some other project, open source project, that's fine. If they know how to do some version management, how to do some unit testing, and some basic core skills, if they learn, I think a lot of startups will be interested in giving small projects on a freelance basis, or have these remote interns or virtual interns who can work online. And when you get it to that level and we're comfortable with the process a little bit, then we may want to scale it. But we want to do all the experiments where we can physically see people initially. And the first year was spent just running these build to learn events, and as I mentioned, sometimes it was 20 people, sometimes it was 80 people. Once I think it was like almost 120, and we had to show them off because we didn't have enough space. But we are going to try different experiments. We're going to change the metrics on not how many people come to these events, but how many products or micro products are built in a year, and that is going to be our focus. And sometime by the middle of the year, or maybe within after 3 to 4 months, we may start experimenting with some other locations.
Oh, wonderful. As always, Dorai, it's very, very energizing to talk to you right from the time. I think we met first in '95. I think when you were describing the business application builder. I still remember the first meeting that we had. I'm very amazed in terms of how you keep abreast of technology, not only knowing about the keywords, but actually applying them where they fit in and putting them to use. That is converting your ideas into action. And of course, the energy, it's very contagious, I would say. Those of you who met you will definitely know that, and I can definitely vouch for it. I keep telling a lot of people that Dorai has been my inspiration for a lot of things, now, particularly, keeping in touch with what's happening and then coming up with alternatives, coming up with ideas and all that. I don't know how you manage time with all this. I'm really thankful that you were able to spare some time for this. I think there are a lot more questions. We might probably need to do one more session, but I don't want to make this too long so that people who listen can take away a lot of things from here and then start applying them.
Yeah, thank you very much. You see, I think it's easy to get excited about certain things, right? And you've always been excited about certain aspects, like quality, for example. And I still remember first meeting. I think I came to the TUL. Gopal organized it, and I came and gave the first talk, I think, to a bunch of people.
Yeah.
This is even before you joined, Integra.
Right.
And then we had so many interactions after that. And I think finding time, if it is important, is it's not a big problem, right? If you're doing things that you like doing, you have the whole day open. Like I'm at a stage where I have grandchildren, and other than my wife, there is nobody else who's going to demand a lot of my time. And she has been very reasonable right from the day we got married. So she lets me do lots of things, in whatever way I want. And so I do have a lot of time. And then I love technology. And then working with young students, it generates. I tell you, they're amazing. Whether they know things or not, whether they have a problem or not, the current generation is extremely inspiring because they are some of the most innovative and socially conscious generation that I have seen. I mean, I keep looking at some of them and keep asking myself, what was I doing at this age? And I think I was just mostly reading science fiction books and chatting with my friends. And here there are people who are doing some really amazing things. So I draw my inspiration from working with young minds. And then startups, that is the other community where people go far beyond their calling, in terms of, the effort they put in and all that, and how they work, and they're smart, and they're always facing problems. They know how to solve problems, and they're like eternally optimistic. And so it's the couple of communities where, there is nothing but energy and optimism. And you have to be lucky to be, among all these people. And that is the part I cherish the most. And of course, spending time, if you are really interested in doing what you're doing, then is not a big issue because you can always find time.
Thanks, Dorai, once again. Thank you. If you like the show and would like to share your experiences with the community or know someone else who might want to do that, please get in touch with us at podcast@pm-powerconsulting.com. That is podcast@pm-powerconsulting.com.